Let me consider this integral using two methods. The first method, I start with multiply numerator and denominator both by something like this, minus 2, square root 2 minus 1 plus minus x minus 1 plus x dx. Well, it's obvious, right? This plus this, I multiply this minus that, and this will be 2, right? Minus, this is square, isn't it? 1 minus x plus this 1 plus x square. Okay, I multiply this one, both top and the bottom, so the denominator changes to this. This is square minus that square. And this one is equal to integral, and this will be, the numerator is the same thing, not changed. 1 plus x, and this is changing, right? This will be changed to this square plus that square minus plus twice square root, right? 1 minus x 1 plus x. Yeah. Okay. Dx written there is better. This is numerator. Okay. So good. Now then the numerator is root 2 minus square root 1 minus x minus 1 plus x square root dx. This x and x cancel out. 1 plus 1 is a 2. Okay? 2, and a 2 minus 2, no more 2. So you have a negative 2, right? Negative 2, yeah. Square root 1 minus x 1 plus x. Yeah, good. Lots of detail in algebra. This is 1 half 1 half. Then I have 3 integrals. This over this, this over that, this over this, right? The first one, the integral from 0 to 1, root 2 over this. This is a square root of 1 minus x squared, isn't it? Dx. That is the first integral. The second integral is a negative integral from 0 to 1. And this cancel with this, right? Left over with dx and square root 1 plus x, isn't it? And the last one is integral from 0 to 1. This cancel with this. So 1 minus x. Yeah, good. Now, this integral is easy. Is root 2 times arcsine, right? Arcsine x, yeah. From 0 to 1. Now that integral, we just use power function, right? This equals 1 plus x, the negative half, right? D 1 plus x. So this is equal to minus plus 1, right? So 1 plus x plus half. So this one is equal to 2, right? Square root of 1 plus x. Okay? So these are just basic training of integrations. So I believe you think you know how to do it, right? It's equal to 2 square root. Okay. And this one, because you have a negative x here, so it becomes positive, right? So positive, the same kind of techniques in the integration. So from 0 to 1, from 0 to 1. So it's end up with 1/2 this is square root is this is half, right? Yeah. Minus 2, this will be root 2. Root 2 minus 1, isn't it? Plus 2, 0, minus 1. So it's end. The calculations, well, the answer is this. I think I can omit the detailed calculation. That is a result. Okay, this is method 1. Now method 2, the integral dx from 0 to 1 root 2 plus 1 minus x plus 1 plus x. Okay, that's the integral. Now, second method, I'm using substitution. I let x be sine 2 theta. Later I will show that where come this idea, why let x be sine 2 theta. This integral is equal to integral, the dx will be 2 cosine 2 theta, right? d theta. Root 2, this will be plus square root 1 minus sine 2 theta plus square root 1 plus sine 2 theta. Okay, good. Then this one equal to integral from 0 to 1. 0 to 1. This is 2 cosine 2 theta d theta. Now, this square root, this is a sine theta, cosine theta. Now, let me explain verbally because too much writing. Okay, this is a sine square plus cosine square. Minus 2 sine cosine. Sine square cosine square. Minus 2 sine cosine. Which means what? Which means sine theta minus cosine theta square, isn't it? Yeah. This is the reason why we make assumption x equal to sine 2 theta, because that will create a perfect square in the square root. Plus the same reason, right? This becomes a square root sine theta plus cosine theta square. Yeah. Now this boundary has been changed. Yeah. When x is 0, theta is 0. When x equal to 1, theta is equal to quarter pi. Sorry, quarter pi. Yeah. Then this one is equal to, I have to go slowly because very easy to make a mistake. This, well, 2 cosine 2 theta d theta square root 2 plus, when you cancel the square root with the square, you take absolute value, right? Absolute value, sine theta minus cosine theta plus absolute value, sine theta plus cosine theta. Now, of course, we take positive value between sine and cosine. So this one is equal to 0 to quarter pi 2 cosine 2 theta d theta. Now, when theta is between 0 and a quarter pi, cosine is greater than sine, isn't it? So we are using cosine minus sine. Yeah, because this is greater than that. For that, there's no problem because they are both positive, right? So it becomes sine theta and cosine theta. And then this becomes this is what? This is a root 2 plus 2 cosine theta, isn't it? Sine cancel out. Yeah. And cosine 2 theta is 2 cosine square theta minus 1, isn't it? D theta. So this one is equal to 0 to quarter pi. This is a 4 cosine square theta minus 2 d theta. And let me write it 2 cosine theta plus root 2, isn't it? Then this one is equal to, from 0 to quarter pi, this is a 2 cosine theta plus root 2 times 2 cosine theta minus root 2 d theta over 2 cosine theta plus root 2. You see, that one is cancelled out. So end up with a quarter pi 2 cosine theta minus root 2 d theta, you see? Yeah, so this one is equal to, this is 2 sine theta, right? from 0 to quarter pi minus root 2 theta, so quarter pi. So sine quarter pi is a 2 root 2, right? Root 2 minus root 2 pi over 4. Yeah, that is common factor out. So 1 minus. Yeah, good. So that is a same answer by method of 2. It's a very good method, and these are good training for basic techniques of integrations. So these are very good examples. I did spend time to select some good questions, which is really good for for improving the basic techniques of integration. Thank you.